So in 5.1, we're going to start looking a little bit more at the area under the probability density function, um, because area is equal to probability. Now, what you're looking at here is really kind of the anatomy of a uniform distribution, where here's the probability density function, and it's defined by this equation. F of x is equal to 1 over b minus a. Now, what's b and what's a? Well, b is this maximum value of the probability density function, and a is this minimum value of the probability density function. So the height above the x-axis here is determined by 1 divided by b minus a. So I'll kind of show you kind of an example of where that comes from here in a think, pair, share. But again, try to hit home that the area underneath this distribution curve, or this horizontal distribution line, area is equal to probability, and the total area underneath it is equal to 1. So remember, one counts discrete data, but one measures continuous data. And for continuous probability functions, probability is equal to area. So let's look at the definition of the area of a rectangle. So the area of a rectangle is equal to width times the height. And the width you could think of as the change in the x values. So change in the x values times change in the y values. That would be the height. So the change in the y values. And in a lot of science classes, you tend to see the word change written as a triangle. So this means change in x times change in y. So change in x, change in y. All right. And remember that the area under the curve is equal to probability. So what I'm doing down here, saying notice the area under the PDF is a rectangle. And so here we've got this rectangular area. And this rectangle has width and height. And that's what we need in order to calculate the area. And so what's the width? Well, the width is the change in x. So the width is going to go from 8.8 to 2. And so if we take 8.8 and subtract 2, that'll get us our width. So that'll be a width of 6.8. The height is going to be a difference of 0 from 0.147. And that's our height. So if we wanted to calculate this area, the area of the rectangle is going to be width times the height. And the width we said was 8.8 minus 2. And the height is 0.147 minus 0. 8.8 minus 2 comes out to 6.8. 0.147 minus 0 just gives us 0.147. And if you multiply these two numbers together, you're going to get 0.9996, which rounds up to 1. And so the area, total area under the curve is 1. The total area under the PDF function is 1. So as a consequence, the probability of getting some value of x that's between 2 and 8.8 is 1, or there's a 100% probability that a value of x is chosen between 2 and 8.8. So let's look at an example where we're not calculating the entire area under the curve, but maybe just a part of it. And what we're trying to calculate is what's the probability that x will be a value between 3 and 6. So between 3 and 6. And so we want values of x that are less than 6, so that'll be from 6 to the left. And we want values of x that are greater than 3, so from 3 and to the right. So that's going to be defined by that rectangular area. So if we want to calculate the probability that x is greater than 3 and less than 6, we want to calculate the area of the rectangle from 3 to 6. So the area of a rectangle is width times the height. And the width is in the difference of the x values. So here's our width. What's the difference? It's between 6 minus 3. And how about the height? It's going to be a difference of 0.147. So here's the height. So 0.147 minus 0. So that's going to get us 3 times 0.147. So the area of our rectangle is 3 times 0.147. Which is 0.441. So the probability that x will be greater than 3 and less than 6 is 0.441, or 44.1%. Okay. Let's see here, part B. So what is the probability density function for the given continuous probability distribution? All right, so that's actually given to you right here. All right, but where did that come from? So for a uniform distribution, the probability of x occurring is equal to 1 over b minus a. Now, b is the maximum value in the uniform distribution, and a is the minimum value in the uniform distribution. Well, what's the maximum value? The maximum value is right here, which is 8.8. And then what was the minimum value? The minimum value is right here, which is 2. So the probability density function is going to be equal to 1 over b, which is 8.8, minus 2, which is 1 over 6.8. And 1 divided by 6.8 comes out to 0.147, and I'm rounding. And so using this formula, we're able to calculate the probability density function for this uniform distribution. And notice that this function that we calculated, and this value on the y-axis, is the same one that we just calculated here down below. All right, we're going to get into a little bit more detail here in the next section, but I think that that is enough for section 5.1. Okay, let me know if you have any questions.